Today I will be talking about the tips and best practices for using UE4 and MR with a particular focus on performance. So I've broken down this presentation into three parts. The first one, we're going to talk about the project settings. Generally, when you're starting in Unreal Engine, there's a myriad of options that you can choose from, and it can become very confusing. And so when we're specifically talking about mixed reality, there are a particular set of settings that you want to choose to give you the best performance when starting out. And that's what we're going to start with talking in the beginning. Then we're going to talk about materials. We're going to talk about how we can use the material editor effectively and what some of the settings are in order to create materials which are very, very performant. And then we'll wrap it up with some quick pointers to some helpful concepts. Now, I've provided a link at the bottom. You will see that a lot of this information is already there on our website for performance recommendations for Unreal Engine. However, some of this information is still new and hasn't been updated, but hopefully it will be very soon. So as I said before, let's start with the recommended project settings, and we'll go through each of the project settings one by one and try to explain them in a bit of detail. You can find all of these settings that I'm talking about in this section under the Edit and Project Settings. So we'll start off with the target hardware. This should be pretty straightforward. We should always be targeting mobile/tablet because we don't have a full desktop processor in our mixed reality devices. And you should set the setting to scalable 3D or 2D, and that way it'll help our engine scale up performance up and down depending on what your scene is like. One of the major decisions that you can make in the project settings is what type of renderer you want to choose. Now, you can choose the default, which is the deferred renderer, or you can choose the forward renderer. We always recommend that you go with the forward renderer for mixed reality. It has a faster baseline. It is in general a faster renderer specifically for mixed reality, and you will see it recommended for VR a lot as well by Epic. However, the main reason is not necessarily because forward rendering in itself is faster, but rather because forward rendering allows you to choose and pick the individual features that you want to turn on and off. And those are the things that we will see as we go along. The particular features that we can turn off that would not be possible when you're doing a deferred renderer. So here's one example of what I was talking about. So if you open up mobile features, you will see options such as vertex fogging. And generally, you can disable that in mobile shaders. So you can say, let's turn off vertex fogging because we don't need it. Generally speaking, in AR, fog is going to be difficult to see. And so you can turn it off in order to obtain or get back some of the performance that you were losing. The other thing is that shadowing in general is pretty slow. And so what you can do is you can set an upper limit on the number of shadow maps that Unreal uses. And the technique that Unreal Engine uses is called CSM, or cascaded shadow maps. And so you can choose, generally speaking, if you set it to 1, that's a good number because at the resolutions that you're running augmented reality in, you will not be able to see more than that usually. Another feature that is usually pretty common and pretty useful in desktop games is occlusion culling. And occlusion culling basically means that you can cull or get rid of objects which are behind other objects. So if you have a large wall and you have a couple of enemies hiding behind that wall, normally they're occluded, you can't see them. So the GPU benefits from occluding them, saying, okay, I'm not going to draw those. However, in order to make that calculation, in order to say whether something is occluded or not, even that in itself requires computation. Now, when you are doing mixed reality, especially when you're doing augmented reality, you will see that a lot of the times it's the real world and you're augmented a couple of virtual objects in front of it. And so because there are not that many objects on the screen, There's not that much occlusion going on. And so the computer, the GPU, is spending more time doing the occlusion query calculations rather than benefiting from the occlusion queries themselves. And that is why, especially for AR, it is a good idea to just turn occlusion culling off. If you actually do need occlusion culling and you think that it is going to be beneficial, then in that particular case, you might want to enable software occlusion, which is another option. However, do keep in mind that software occlusion is going to then start taxing your CPU rather than your GPU. So if your frames are being limited by the power of the CPU, then enabling software occlusion is not necessarily going to benefit you either. This is another one of those common sense things. Anytime you are required to do extra passes, that is more compute work, it is going to be slower. And the problem is that a lot of the times people don't know what it is that Unreal Engine is doing that will require more passes or more compute. And so translucency is one of those things that is very, very slow. And generally, you should avoid it as much as you can. The other thing that requires more work is the depth stencil. It is not something that is used very common, but just do understand that if you use the depth stencil, then that's going to require a whole extra pass. And again, that means that it's going to be doing more work. So if you can disable it, go ahead and disable it. For most of the time, you should be able to disable it. Again, things which we take for granted on console or on the desktop, like bloom shaders and so on, which are post-processing effects, they will generally require another pass, especially if we're talking about the full screen post-processing effects. And so ensure that you turn those off if you're not actually going to be using them. Instant stereo and mobile multi-view are those nifty features that are specifically developed for mixed reality. Normally, when you're watching a movie or when you're looking at something on the computer screen, it's one screen that you're looking at. Or even if it's multiple monitors, it's basically from one point of view. However, human beings have two eyes, and each of the eyes sees a slightly different image. And so the computer has to basically do twice the work in order to do VR than it would normally, because it has to provide two different images from two different, slightly differing viewpoints. And that slightly differing, those two words are critical, because that realization that they're almost the same, but they're different in very small ways, is something that engines like Unreal Engine can use in order to take information from just one render or one frame and then use that information to reuse that information as much as possible for both eyes. And therefore, instant stereo and mobile multi-view should be turned on, and they should provide significant performance speedups. Now, this tip is not necessarily so much related to performance in terms of the actual running program as much as it is with the workflow. So one of the problems that with the way that Unreal Engine optimizes things is that it tries to do a whole lot of stuff at compile time, which is great. However, the downside is that there's a lot of shader recompilation that has to happen. So the techniques that Unreal Engine uses behind the scenes is that it creates a lot of permutations of your shaders, and then it allows those permutations to switch depending on what you're actually trying to render. Now, one of those permutations that you can just entirely get rid of, if you know that your lights are not really going to move. So if you don't have mobile or movable spotlights or point lights, then you can set this value to 0. You can set the max movable spotlights to 0. And the benefit of that is that it will eliminate a certain set of permutations that have to be generated, and that should speed up your shader compilation. So now that we have the project settings out of the way, let's talk about materials. Materials can have a huge impact on your rendering performance. Now, most people already know how to create materials and how to atlas them or how to do a lot of stuff. But what I want to talk about right now are things specific to the way that Unreal Engine deals with materials. And those are perhaps things that you wouldn't normally know. So one of the things that you'll have to do pretty regularly is UV computation. UV computation basically allows you to take a texture that is fed into a material and then either tile it or scale it up or scale it down, do different kind of math on it. And this is pretty useful. So if you have a couple of brick images, for example, you can then tile those so that it looks like you have an entire wall made out of brick. Now, the standard way that you would probably do it is the way that I've shown you this on in the material graph, and you'll see that normally you'd provide something like this. So you'd say this is a number 4 by 4, it's a vector, and it's being multiplied by the texture coordinate over here. And this texture coordinate is then multiplied with the number that you have, and then that is fed into the texture sample over here. And you will see that then this goes into, for example, your normal, right? And of course, it's not just for the normal. We did something similar over here. You can't see it, it's slightly outside, but you'll see something over here basically, and then you'll see that ultimately goes into the base color. Now, on the surface, this looks like this would be a good way to do this. However, don't do this. This is the wrong way to do this sort of calculation. Why? Because if you do it this way, which you can, and you might need to in some cases, but in general, what is happening is this calculation is happening in the pixel shader, which means that it is happening at least once for every single pixel on the screen. Now, ideally, what you want to do is you want this to happen in the vertex shader instead. So let's look at what I mean by that, right? So the way to fix that problem is to use customized UVs, a feature provided by Unreal Engine, right? So if you look over here, you will see that I have 2 extra pins over there. And I've provided 2 as an example, but they don't have to be 2. You can just have 1. In this case, I'm only using 1. And this is something that will not be visible by default, but I'll just show you how you can make that visible. And once you make that visible, then instead of passing in the textual coordinate multiplied by your vector 4 by 4 directly into the normal or into the base color, you would rather put it into a customized UV, and then that would allow you to manipulate the UVs in general, which are then passed into your base color and specular color and so on. And so that it'll give you the same tiling effect that you wanted, but it'll do that by providing that information via the vertex shader instead, which is much faster. So the way to do that basically is if you open up your material editor for your material, you'll see several different settings that you should be used to, which are the material domain, the blend mode, and so on. However, there's an extra little option there called num customized UVs, and if you look at that option, you will see that I have set it to 1. And as soon as you set it to 1, you will see an extra pin appear over there. And of course, you can have this different numbers. If you have it to 2, you'll see 2. And then those customized UVs are UVs that you can use in order to do your own multiplication. And that is the value that will be interpolated coming from the vertex shader. I provided a URL over here for you to basically go online to the official Unreal Engine documentation and learn more about this nifty feature in more detail. When you're running on a desktop computer, usually you have 32-bit precision or even 64-bit precision in order to do calculations, and they're far more detailed. They're better rendered in terms of precision and accuracy. However, on a mobile device or mixed reality, augmented reality, it is far more important to have better speed, and we can lose some visual fidelity. And therefore, generally speaking, you should not be using full precision because that will be slower. So it's something that could be easily turned off without having too much of a visual hit. Other things that you can turn off are things like, for example, dialing down the light map information. Now, the light map information is actually pretty useful because it stores a lot of the lighting information offline. However, how much of that information is actually used in real time can be dialed down. So, for example, the ambient information can be still used, but information, directional information, for example, you can turn that off because, again, in augmented reality specifically, you will most likely not notice that loss as much as you would in a real-time, say, console game or a desktop game. And so again, turning it off will be very little visual loss, but it would be a performance boost. So again, your mileage may vary. Do perform your own tests, but it could certainly give you that performance boost. A very important thing to keep in mind when you're creating materials, especially when you're creating material parameters, is to try to prefer to use static parameters wherever possible. Now, static switches can be used to remove entire branches of the material with no runtime cost. So because they're static, it means that they are calculated at compile time. And so entire branches or permutations of a shader will go away at compile time. And the benefit of that is that your instances can still have different values, right? So what that means is that it's possible to have a templated shader setup, right? So you could have different templates. So one could have one color, another could have another color, and you'd still have those instances. However, you wouldn't have the performance loss, right? The downside, though, of course, on the one end is that some things are simply not possible, because if you want to change certain things at runtime, you will not necessarily be able to do them using a static switch. However, the biggest downside is that this creates many different permutations. And I talked about permutations earlier in the presentation as well, where basically Unreal Engine sort of creates multiple versions of a material and switches between them, giving you the feeling that you're changing a particular parameter. And the downside, as I said to that when I was talking about this earlier, is that this requires a lot of compilation. And so every time you create a static switch, although you will gain performance at runtime, you will lose time to performance, you'll lose time to shader recompilation. And so try to minimize the number of static parameters in the material and the number of permutations of those static materials that are actually used. And that's sort of a good compromise. In a similar vein, you should always give preference to creating a material instance constant over creating a material instance dynamic. A material instance constant is an instance material, but it is calculated only once prior to runtime, just like I talked about the static switches. Now, in case you're wondering, well, how do I know if what I'm creating is a material instance constant or whether it's a material instance dynamic? And an easy way to know that is that if you go to content browser and if you right click and create material, like I'm showing you in a slide, that is going to by default create a material instance constant. The dynamic ones can only be created via code because they are dynamic. And so therefore, if you are not creating material instances via code, then you are creating and most likely creating a material instance constant anyway, and that is generally more efficient. So we're almost at the end of the presentation, so I want to leave you with just a couple of quick tips before we end the presentation. You should try to use Unreal Engine's built-in tools as much as possible rather than reinventing the wheel. If you feel like there's something that you're writing a lot of code to accomplish, there's a very, very good chance that it's already there somewhere and that you just have to find it. Let me give you an example of what I mean. A very common thing that you generally need to do in augmented reality is to try to see various configurations of an object in the real world. So you either want to see how somebody would look like with a particular sunglasses, and then you want to try different ones. Or for example, you want to see how a particular piece of furniture would look in your room, or you want to see how a particular car would look like with different configurations. And so you would think that that is something, because it's so common in AR, that Unreal Engine would have something built in. And luckily, yes, it does. So instead of going in and then writing a bazillion different configurations for that, there's something built into Unreal Engine called the Variant Manager. So do learn more about the Variant Manager. I'll leave you with that keyword, but go ahead, type it into Google or search engine, whatever, and try to see if you can find out what a Variant Manager is and how Unreal Engine can help you write a lot of these different configurations without actually writing any code. The second thing is the spline component. So if you are doing things like a lot of animations, right? A lot of the times I've seen people trying to do some funky math in order to do some animations, simple animation like having an object go from point A to point B, for example. There's a perfectly nice component built in called the spline component. Notice I'm not talking about the spline mesh component, which is different. I'm talking about the spline component, and basically allows you to create arbitrary curves. And you can use information from that curve to do anything. However, one of the great things is to combine it with another component called the timeline component. And you can use the timeline component to give you an interpolation value, which then you can plug into the spline component, which gives you the position. And that way you can have a completely non-programmatic way of having objects animate in very complex ways. And you can make them move faster or slower because you have connected it to a timeline component. The final tip is do as much work at compile time or startup caching as possible. And that will allow you to speed things up at runtime because you've done a whole lot of work at startup instead. And an example of this is you can cache object references during on begin play of a level blueprint. And I'm not talking again about the object blueprint. Most people forget that there's a level blueprint, maybe because they're coming from Unity where there's no such thing, or they're just simply not used to seeing it because it's not used as much. But do use the level blueprint. It can be a great way of, at runtime, at startup, finding out all of the different objects that you need, and then caching different references to them so that you don't need to keep referencing objects again and again and using an expensive find object. Again, a similar thing, but you can use things like construction scripts. Construction scripts are amazing. They allow you to run entire scripts during compile time when you are setting things up. So they can be used to do things like they can be used to verify stuff. So if you're procedurally creating, for example, a room or a variation, the construction script at runtime, or sorry, at construction time will be able to perform different checks and say, can this particular thing actually fit in this particular room or not? So before it starts off, and it can even correct stuff before you actually compile it. So that's it for today. Thank you so much for listening, and I will take any questions now. Thank you.